We have the activity on our analog devices wiki here, where we are making the electric microphone preamplifier. So our objective of this laboratory is to explore the electric microphone bias techniques in a two-stage preamplifier circuit. Here are some notes here. As in all the ALM labs, we're going to focus on terminology referring to the connections M1000 connector and configuring the hardware. The green shaded rectangles indicate connections to the M1000 and the analog I/O connector, where the analog I/O channel pins are referred to as CA and CB. So CA and CB are the analog channel pins. When configured to force voltage or measurement current, it's added in CAV, or when configured to force current, measure the voltage as -I. So -V is voltage, -I is current. Then we have more information about when a channel is configured in the high impedance mode to only measure voltage, it's added as CAH. So that's another piece of note right there. Scope traces are similarly referred to by channel and voltage current, such as CAV, CBV for the waveforms, and so CAV and CB are for waveforms, and CAI, CBI for the current waveforms. So voltage, and we have current waveforms. And then our channels are going to be CH-H. So we're going to look at that in the circuit in a second. Here's our background. The electric is a quasi-permanently charged dielectric. It's made up by heating a ceramic material, placing it in a magnetic field, then allowing it to cool while still in the magnetic field. It is the electrostatic equivalent of a permanent magnet. In an electric microphone, a slice of this material is used as part of the dielectric of a capacitor, in which the diaphragm of the microphone forms one plate. Sound pressure moves the diaphragm. The movement of the plate varies the capacitance according to the sound pressure. Given the built-in fixed charge of the dielectric, the voltage across the capacitor will also vary. The electric capacitor is connected to the input of a built-in FET amplifier. The electric microphones are small, have excellent sensitivity and a wide frequency response, and generally are a very low cost. We have the terminals for this electric microphone preamplifier or amplifier. We're going to make a preamplifier for our amplifier. We have this mark on the side right here, and this mark, if there's no other positives or negatives, indicates a negative. So if it has a mark like this, it's negative. Without the mark, is going to be positive. We have the materials list here, and then we have our directions right here, which is what we're going to look at. We're going to come back to this when we actually build the circuit in the next part of the video. So for the hardware setup, to produce a sound to pick up with the microphone, a good choice is a small 8 ohm audio speaker, which we have connected to the channel A voltage generator output, CAV, as shown in figure 2. A mechanical or Pfizer electric buzz or transconductor could work to produce a sound as well. We're going to set the channel A to produce a 1000 Hz sine wave with a 1 volt min and 4 volt max value. We're also going to position the speaker near to and directly facing our microphone. Scope channel B is set to high Z mode and is set to 0.2 volts, centered at DC value at the output is 2.5. Then we're going to come back to these instructions when we actually test it. We then have our procedure, which is to change the frequency of the generator and observe the amplifier response of the combined speaker and microphone. We're going to measure the amplitude of the signal seen as the base Q1 and calculate the gain of the preamplifier. So now we're actually going to build this circuit. So as you can see, I have already built this circuit. Now it doesn't work as it should though, and even though it's already built, we're going to go over each of the individual parts for this. So the first part is establishing our 5 volts and ground. In the software, we have our analog discovery 2 hooked up. That's what these wires are coming from. And we can see that this black wire is ground. So this black wire is going in here, grounding out this entire negative side. So this negative side is ground, and the 5 volts is going to be this red wire. So the entire red rail is live. Now we have the blue and the orange wire here. These are the other probes from our analog discovery, the waveform probes to monitor. These are going to be grounded as well. And then we have our probes to monitor, which we're going to look at in a second. So if we look at this, we're going to start off from the top, which is the 5 volts. So we have our 5 volts, and we know it's the red rail. Well, let's read from left to right. So we have R1, which is 1 kilo ohm. And where is this 1 kilo ohm? Well, the 1 kilo ohm is going to be right here. And it's in the middle, so that can be, yes, a little bit confusing. But when we make things on breadboards, typically it doesn't look like how it does in the actual circuit diagram. It can, but for a small breadboard like this, it's really hard to make it look like that. We have 1 kilo ohm resistor right here. We can see that it is from 5 volts into the speaker, or the microphone. This is not the speaker, this is the microphone. In the microphone, remember what we said earlier? How if it has the solder points, it's a negative. So the solder mark means negative. If I'm to lift up this microphone right here, we can see that it's in the same column as the resistor and the wire that's grounding it. If we pull it out like this, we can see that the solder point is on this one, which is connected through this green solder right here. These two are connected, and these two are connected. So that means this is negative and this is positive. So when we wire this up, the positive is going to go inside like this. So we can plate this back in here, the same column as our resistor and the same column as our grounding wire. And we're just going to push in like this. Now we can see that we have a 10 microfarad capacitor with this. The positive side being the positive side of our microphone. So this is the positive side. The negative side is denoted with this little negative part right here. And we can see it is a 10 microfarads. It's in parallel with this resistor. So there's the node right here. We have a node right here, and it's going to split off. So that's going to be it for this part. We hit this capacitor. Now this capacitor is going to have 2 connections, but we're going to come back to that in a second. Going back to the 5 volt at the top, let's now look at our R2. So our R2 is the 20 kilo ohms. Well, where is this going to go in? This is this right here, this part. Now, I do not have a 20 kilo ohm resistor. However, I do have 2 10 kilo ohm resistors. And so what I did is I put these two in parallel with each other. They're both 10 kilo ohms, and now, or not parallel, sorry, because in parallel it would make it split. It would make it 5 volts each. But they're in series with each other. We can see it goes from our live into here, and then connects straight into here, which is going into the collector of this transistor right here. And I'm going to have a diagram of this on screen. So this side is the collector, the left side, the middle is the base, and this side is the emitter. If you look at the diagram, the base, it looks like there's a line inside of the circle. You can think of it as, well, there's this line right here, and there's the circle across of it. So that's how I like to look at it. This is the big side where we have our collector, our base, and then the emitter. So this is going inside of our collector right here. When we look at our circuit diagram, it's in the same direction. So the 20 kilo ohm resistor goes into the collector, but there's also a node here because it's going to have this wire that goes from the 20 kilo ohms before it goes into this collector. It's going to go to the base of our Q2, which is the other transistor, which is right here. It goes into this base, which is in the same column, the middle part. So now we also need our Q2 wire to 5 volts, right? Through the collector, as we can see. So this wire is 5 volts, and it goes to the same column as this collector right here. So this is sending 5 volts through it. Now let's look at the row underneath. We've established everything. So let's, again, left to right. We have our 10 microfarad capacitor, right? And we can see that it goes from the 1 kilo ohm resistor. It's in parallel with it. It's going to go out this way, and it's going to end right here. Now it's going to connect to the base of our Q1, which it does right here. But it's also going to split and go to a 10 kilo ohm resistor. So this is the white wire, and this is going to go like this into right here. And then this right here, this resistor is our 10 kilo ohm resistor with it. So we're going to come back to this when we finish the circuit. This whole part is a little part that we're going to come back to. Let's move on to our Q1 though. So our Q1 is this transistor right here. So we've covered the collector, we've covered the base, and now let's cover the emitter part. So the emitter part is right here, right, this last part. And we can see in the circuit diagram that it's going to go out to R6 and C2, a 10 kilo ohm resistor and a 47 microfarad capacitor. So we can take this wire, this white one right here, from the emitter which is in this row or column, and we're going to take it all the way across here, and it's going to go like this. And so it's going to be in parallel, we can see from the circuit diagram, it's in parallel with this 10 kilo ohm resistor and this 47 microfarad capacitor right here. And then we have the wire that's going to take it down to ground. So the entire left side of our circuit is basically done. Let's keep looking at this. Well, from the 10 microfarad capacitor, remember we said it's this one, we have it connected to a 10 kilo ohm resistor. Well, right above that, we can see it's in parallel with a 1 kilo ohm R4 resistor, right? So, and that's coming from Q2. And our Q2 is this transistor, and it's coming out of the emitter. And the emitter is going to be the very far right. So it's going to be this one right here. We can see that the resistor and the emitter are in the same column. And then it's going to go from here, and it's going to terminate in the exact same place as our 10 kilo ohm resistor, which is right in this column right here. So we can see the 10 kilo ohm terminates there, the 1 kilo ohm R4 terminates here. And then we have a 1 kilo ohm resistor across here that's in parallel with a 220 microfarad capacitor, and these are both going to ground. And again, this is on the very bottom right hand side. And that is going to be it. Now, there is one more thing to note. Out of our transistor, we have our CB-H. And that is going to be a channel wire because we want to monitor this. So I use channel 2. That's this blue wire. It's hooked up in here. Make sure it's also hooked up to ground as well. And that's how we're going to be monitoring it. That's our circuit for the microphone and the preamplifier. Now, let's look at something else. Our speaker. Well, this speaker, we can see, looks like this, right? It has a red side and a black side. And we want to have our white wire, or yellow wire, the solid yellow wire, go into the red side of our preamplifier, or not the preamplifier, inside of the speaker. And then the other wire, the yellow wire with a green or white stripe, is going to go into the black side. That's because we want to send a 2.5 volts through it, and we want to make it emit a sound. That way our microphone can hopefully pick it up. So what we can do is look back at our supplies. And then we're going to stop the breadboard right here. If we need it, we can always come back to it. Everything looks correct in our circuit. However, there is a few things that I need to make note of. The first is that we have our overcurrent protection whenever we turn on just the power supplies, right? Not our WaveGen 1. So we know it has to be a problem with the way something is delivering power. Now, I've actually had a problem with this microphone. It doesn't seem to be working. Not sure why that is. Could be from the parts kit that I got, but we can test the individual part. We'll test the preamplifier part, which is this entire part right here to the left. Again, our connections are good. They're good. So what we can do is make sure the WaveGen is off and everything. Supplies and everything are off. We're going to move this capacitor from here to here, and we're going to just test this. So we want to unplug this, not deal with the speaker for now. We can put this into here. We're going to simulate a wave. And then we want to have our scope monitoring probe right here as well. So we're monitoring the output and also the input. So if we go to our waveform, we're going to go back here after we've made these changes. Again, we're leaving this here, we're just moving the capacitor over here, and then we're monitoring it with this and sending a sine wave through this to see if it works. After we turn on our scope, our supplies, and our channel 1 waveform, we have 1 kilohertz, 1 millisecond, 2 volt, 0 volt offset. And then we go back to our supplies right here. They're on our scope. These are the settings for it. Make sure that our level is on the channel 2. And it's just somewhere in between this blue output right here. So the blue is the output, the yellow is the input. So we know that our first part, which is the preamplifier part, is working because we have some input signal and then we're getting some output like this right here. So that's working. Now we're going to test the microphone. A super easy way to test this is just by putting some current through it just to see if it'll go. So we have a battery here, and it's hooked up to this power supply. I'm going to just turn it on. You can see nothing lights. To complete this circuit, because currently it is a open circuit, we're just going to short it with this. We have our positive side here and our negative side there. And so we were going to just put this in and connect the two columns together and turn this on. We can see the LED turns on and lights up blue. It's very faint, but it does light up blue. If I turn it off, we can see that it turns off as well. So that's one way to test it. Now, another thing we could do to actually test this is go back to the board that we're currently working with right here. And well, we know we have a positive and we have a negative side. So this one's positive and this one's negative. So we're going to plug it in just like this. Our 5 volts should run through the resistor and into our positive terminal here, and then negative will go into the ground right here. And that's how it is for the circuit as well. So now that that is for certain, we know this, we are going to take a look at how we can output this to our waveform. And if we are to output this, it's important to note that there's an input signal here. We'll just take this probe, make sure your analog discovery is off, plug it in here so we monitor the input, and let's take this probe and monitor our output, just like that. So what we can do is we can run this, and from here, if the supplies, so this looks like this, I'll turn the supplies on. We can see that it goes to 5 volts, and this is for our input. However, our output stays at 0. So that means that we are not having any output go onto the side of our microphone. I'm not sure why that is. It's probably not working. Again, I believe I have some issues with it. So I think that's the reason why it again is not working. The speaker is working though. So if we are to just put our capacitor back in, and I'm going to pause the supplies while I do this. Take the capacitor and you're going to put it back inside of here, and even with the capacitor inside of here like this, if we run the supplies, it's still not going to output anything different. What we're going to want to do is we're going to take this yellow wire, the one without the white stripe, and we're going to put it with our speaker, and then we're going to take the other waveform wire that has the yellow and the white stripe, and we're going to plug it in. And if we look at our waveform generator, we should have a 1 kilohertz frequency, so it's going to look like this, a 1 milliseconds period, a 2 volt amplitude, 0 volts offset. Now if we want the sound to be higher, we can change the amplitude. It's 2 volts now. I'll make it 2.5, press enter and run all, and it's louder. That's coming from our speaker right here. Now I'm going to pause it for a second, but if we are to run our supplies, and we can see that we don't really have an output here. Well, you can't really see it, but in the waveform there's no output here. If I am to move some things around with the range, it still doesn't output anything. The blue line is on top here. If we run it like this, it's actually going to give us a overvoltage protection. I believe that's to do with our waveform generator. So currently the waveform generator is at 2.5 volts for an amplitude and a 0 volt offset. So I think the reason why is because this needs to be at 2.5 volts. So you can press enter, we can run all here. Oh, and that is going to turn on as well. So let's turn on our power supplies. And the power supplies does not turn off, which would give us an overvoltage protection. That's good. So we know that our offset needs to be 2.5. I'm going to turn the amplitude down just a little bit because it's so loud. We'll try 2 volts and see if it still outputs a sound. And we got an overvoltage protection because our amplitude is too high. Let's try 200 millivolts. We can run all here. It's a lot quieter. Let's try the supplies. And we don't get an overvoltage protection or overcurrent protection anymore either. So we know everything is working how it should, like this. All of our currents are flowing through properly. And so now we can look back at our board and see if there's something that we can fix here. So our speaker is wired correctly, just like this. Again, we have our analog discovery 2 here. We have the yellow wire without the white stripe, and then we have the yellow wire with the white stripe. And that's going to our speaker right there. Our microphone is right here. Now let's change how we are looking at this. So we either need channel 1 or channel 2. We don't need both. We'll just take out channel 2, place it to the side. We're going to take this channel 1 and we want to put it on the output of our circuit. And the output of our circuit is going to be the collector of our transistor right here. So we're going to plug it into this very last column, the same one that our resistor is in. From here, what I'm going to do is first I'm going to run the scopes, or the supplies. It's going to look like this for our, again, this is channel 1. We can turn off channel 2 because we don't need that. And then let's run all for our waveform, which is connected to our speaker. Doesn't seem like anything does anything. Let's turn this up to be 500 millivolts. We can run all. Oh, and it looks like we are getting something. It stopped due to an overprotection for our current. Wow. Let's do this again. We'll try 400 millivolts this time. So changing our amplitude to be 400 millivolts. And what we can do from here now is run our supplies. You can see it varies like this. I'm just touching the capacitor right now, so that's what that's doing. Maybe we need to put this inside of here. Maybe stabilize it a little bit. We can turn averaging on, so we'll turn it to 50, that's on the side of the screen. Turn that on, and we can make our channel 1. We want to make the range. First, let's deal with the offset. It's at a 3 volts right now, so we can bring it down to a negative 2.5. That's what that way, that'll bring it down. So I'll take this and we'll go negative 2.5. This is going to be in volts, so once we do that, we can see it brings it down to the middle. We're also going to want to change our range. Just do 500 millivolts like this. It's going to run like this. We're going to want our trigger level, which is the triangle on the right. We want it first to be on channel 1 because that's what we're dealing with, so we're going to change that at the top right there. And then we want it to be inside of our waveform right there. So it's going to be channel 1 inside of here. We can see the averaging is on, and now we can turn our supplies on as well. So we're going to click run all. And it starts going crazy again. I'm not sure why exactly it's doing that, but that is how it's going to look. Our supplies are not getting the overcurrent protection until now. So it's something probably with the supplies. I'm not sure what it is, but it should be working. I'm not sure why. I believe it has to do with the microphone. That's it for this lab. Again, I think it's for the microphone. Did get full credit for the demo and everything because the preamplifier worked. We can obviously see the speaker works. It's just something to do with this microphone.